Hey, welcome back, Grace. Are you ready? Then hit it!
It's time for Maths with Mr. Thomas.
Yes, it is! And we are almost at the end of the vectors chapter. We have learned everything that we need to know, and now it is just time to answer some old exam questions. Let's give it a shot. Let's see if you can do them. Woo! So, this first question is from 2019. It is paper 2, meaning it is a calculator question. Find the magnitude of a vector P, given that P has the component 6, 27, negative 18. So, Scott, start it off. How do you go about getting the magnitude?
Oh, well, that's when you do the square root.
That is right, Scott. Very well done. It is going to be the square root of what, though, Scott?
Well, it'll be each of the components squared and added together.
Well done, Scott. High five. Which means you will have the square root of the 6 squared plus the 27 squared plus the negative 18 squared. Woo! If you work each of these out then, 6 squared is 6 times 6, which is 36. If you work out 27 times 27, remember it's a calculator paper, so doink, 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 you get 729. And if you do negative 18 times negative 18, two negatives make a positive, and 18 times 18 is 324. If you add all of them together, you end up with 1,089. Thank you, John. And if you take the square root of 1,089, John, you seem determined. What do you end up with then? 33. Thank you, John. Woo! Question 2, again from 2019. However, this is a paper 1 question, meaning it is non-calculator. No calculators allowed. So, in triangle PQR, there's PR, has the component 6, negative 4. And RQ, going from R to Q, has the components negative 1, 8. M is the midpoint of the line PR. Ooh. So, part A, express PQ, the vector, in component form. How do we know it's a vector? Yeah, there's this arrow above it showing this is the vector going from P to Q. So, this is what we're wanting. We want to go from P to Q. That's what you want to find. But do you know that vector? No. You're right, we don't. We're not told PQ, so we can't use that way. We can't go from there to there by going up this road. If you imagine this with roads, imagine these are towns. We don't know this vector, we don't know this road, so we can't use it. So we have to find some other way to go. So instead of going directly from P to Q this way, what else could we do? Excellent! You could also go from P down to R, because we know that vector from P to R. We know that is the vector 6, negative 4. So we can say that is PR. And then where would you go once you were at R? Well, once you're at R, you're wanting to finish up at Q, so we could just go then from R to Q. Do we know the vector from R to Q? Yes, we do. We're told that as well. We're told RQ. We're told RQ is negative 1, 8, which means we would have PR from P to R plus the RQ. PR has the component 6, negative 4, so we can sub that in. And we're adding on the components for RQ. RQ is negative 1, 8. To add vectors, just add the X components and then add the Y components. So 6 add negative 1 would be 6, take away 1. And negative 4 add 8. It's just negative 4 add 8. If you work out 6 add negative 1, you end up with 5. And if you do negative 4 add 8, you end up with 4, meaning that would be our answer. With part B, express MQ in component form. So M, remember, this was the midpoint. So that is the midpoint of the line PR. So how do we go from here, this point M, up to point Q? Good, yeah, well done. Again, I always imagine this as wee roads. Imagine these are towns. You want to go from here to here. You cannot just go like that across the field. You would get stuck. There is no road. What you have to do is you have to go down to R first of all. So we'd have to go from M to R. But how do we go from M to R? Do we know that vector? Sally, help us out. Yeah, brilliant. What we know is we know PR. We know PR is going from P to R, but because M is the midpoint of this, we know that MR would be half of PR, because it's the middle. So we can say that to go from M to Q, first of all, we would have to go from M to R, which is half of PR. Once we're then at R, where do we then go? Yeah, good. From R then we just go up to Q. So we'd have plus RQ. So plus RQ. But if we think back then, half of PR, what is the vector PR? Yeah, we're told that that is the 6, -4. So we've just got half of that vector. We've got half of the 6, -4. And then we're adding on RQ. RQ is just up here. It's -1, 8. With this one here though, what is half of the vector 6, -4? Yeah, brilliant. You just half each of these numbers. So you just divide them by 2. So half of 6 is 3. Half of -4 is -2. So you'd have 3, -2. Add on the -1, 8. And once again, you would just add the x components and the y components, giving you an answer of, well, 3 add -1, same as 3 take away 1. Yeah. And -2 add 8 is, yeah, you got it. High five to you. Woo! You're a genius. Yeah. Let's try another one. Find the magnitude of vector R. This one again, similar to the first example that I just did with this past paper exam questions lesson. How do you get the magnitude? Yeah, good. It's just going to be the square root of each of these components squared and added together. So the magnitude of R will be the square root of the 24 squared plus the -12 squared plus the 8 squared. Woo! If you simplify that bit under the square root, this is a paper 2 question, which means it is a calculator question. So 24 times 24 gives you 576. -12 times -12, the two negatives would make a positive, so 12 times 12 is 144, and 8 times 8 is 64. Yeah. If you add all of them together, you end up with the square root of, yeah, well done, you do get 784, and working that out, if you key that into the calculator, doink, 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 you end up with 28. So, the length of that vector, the magnitude of the vector, the size of the vector is 28 units. Woo! Number 4 from 2016, a long, long time ago in a galaxy far, far away. We've got paper 1, so this is non-calculator. 2 vectors are given by vector u, which has the components 1, 5, 1, and it also tells us u plus v is 6, -4, 3. And we've got to find vector v. Ow, ow. How do we do that? How do we find vector v? Because we're only told u. But we are told that u plus v is the 6, -4, 3. Well, start off with what you know. Yeah, good suggestion. Well done, Kieran. So we know u plus v is the 6, -4, 3. What could we then do? Aaron, you are perfectly right. Yes, because we know vector u has components 1, 5, 1, we can replace this u with the 1, 5, 1. So when we say vector u is that 1, 5, 1, we're still adding on v and it's still equal to the 6, -4, 3. You can see there, all we have done is swap vector u with what we know it is equal to. After that, we're still wanting to find out vector v. How do we go about getting v on its own? Good. With vector v, we're adding on the 1, 5, 1. We're adding on this vector here. So to get rid of that vector, we just take it away, leaving us just with v on its own. But on the other side, we had the vector 6, -4, 3. What do we have to do? Because we took away the 1, 5, 1 in the left, yeah, we take away the 1, 5, 1 in the right. So we would take away that 1, 5, 1. Or just move that over and make it a minus, whichever way you have learned to do this. It means then vector v will equal. And if we've got one vector minus the other, we subtract the x components, subtract the y components, and subtract the z components. So 6 take away 1. We know that. -4 take away 5. You're going further down into the negatives. And 3 take away 1. It is 2. Yeah. Meaning that vector v will have the components 5, -9, 2. Woo, hoo, hoo. How's this going? Number 5 from 2019 paper 2. Calculator paper. The diagram shows a cone that looks slightly wonky with a diameter of 6 units, which means that from one side to the other, that's 6 units. One side to the other, 6 units. That there would be 6 units. That there's 6 units. From one side to the other, it's 6 units. And a height of 8 units. So from the bottom to the very top is 8 units. The x-axis and y-axis are tangents to the base. A is the point of contact between the base and the x-axis. You can see that just there. And B is directly above the centre of the base. So if we just keep coming down from here, that is the centre of this circle, which looks wonky at the bottom. Write down the components. No, it's not. It's write down the coordinates of A and B. So how do we do that? So with point A, we are wanting to write down the coordinates of point A. So we've got our brackets and we're looking for these 3 numbers. Remember, with your X, your Y and your Z axis, we're going to be starting at 0, 0, 0. And you need to think, how do you go from 0, 0, 0 to that point that we are wanting? Just that point A. You need to think, how far along do you go in the x-axis? How far back do you go in the y-axis? And how far up or down do we go in the z-axis? So, if we're starting at 0, 0, 0, going along, first of all, it has to be done x, y, z. It's got to be alphabetical. First of all, how far do we go along to go from here to here?
I don't know. Help me out.
Okay, I will help you. What it tells us is that the diameter of the circle at the bottom is 6 units, meaning to go from one side to the other, we're going along 6 units. But you can see from O to A, we're not going right the way across the circle. We're really just going halfway across to get to that centre. So how far is it then from here to here? How far would that be? Yeah, well done. If you go right the way across, it's 6. If you go from the edge to the centre, it would be 3. So that there is really going from the edge to the centre, just moved back a wee bit. So we know that then will be 3 units. So the x coordinate is just going to be 3. After that, well, we've arrived at point A. Do we have to go back then in the y-axis? No, we're just wanting to go to A. We've already reached A, so we go back 0. And if we stay here, do we have to go up at all to get to the point that we're already at? No, we don't. That makes no sense. So Z would just be 0 as well. So we've got 3, 0, 0 for point A. With point B, write down the coordinates of that. Well, it's very, very similar. You want to start at 0, 0, 0, and you want to think, how far along do you go in the x-axis? How far back do you go in the y-axis? And then how far up do you go in the z-axis? Well, we already know that we're coming along 3 units in the x-axis to get to this point here. So we know for B, we're coming along 3. We then need to think, how far back do we go? Well, because we're coming along 3 here, and it's a circle at the bottom, to get to that centre, we'd also have to come back 3 this way as well. So we're going along 3 in the x and then back 3 in the y, and that takes us to the centre of that circle. So we'd have 3, 3. Then we need to think, if we are at the bottom there, how far up do we go to get to the pointy bit on the cone? Yeah, good. It would just be 8, because it tells us here the cone has a height of 8 units. So that there, from the bottom to the top, will be 8. Yeah! So that's our answer. With this next one, 2018 paper 2, in the diagram, AB, going from A to B, and EA, going from E to A, represent the vectors U and W. It tells us ED, going from E to D, is double the length of AB. So there is A to B. And it tells us EA, going from E to A, is twice the length of DC, going from D to C. Express BC, going from B to C, in terms of U and W. So, in order to go from a B to C, that is what we are wanting to do. Once again, I would imagine these wee places as towns, these lines here as roads. Do we know this road? Do we know the line going directly from B to C? No, we don't. So we need an alternative vector journey. We need to work out, how do you go from B to C without going directly down this road here? Well, our only other option is to do what? Yeah, we'd have to come back this way to A, then down to E, then along to D, and then up to C. We'd have to go the long way around. So if we do that, we would have to first of all go from B to A. So we'd have vector BA. Then after we're at A, we would have to go from A down to E. So we're adding on AE. Then after that, we're at E, so we want to go along to D, so we'd have to add on ED. Hi, Ed. And then after that, we would go from D to C. So we're adding on DC. So what we need to do now is work out what each of these vectors are. So, vector BA, how do you go from B to A? Well, from B to A, we can see that's the opposite of this vector U. Vector U goes from A to B, but if we reverse it, instead of positive U, we would just have negative U. After that, we're at A and we want to go down to E, so that vector there will be, good, it will be negative W, because it's just the opposite direction of W. Instead of going from E to A, we went from A back to E. We're now at E, so we need to work out these vectors. What would the vector ED be? Does anybody have any ideas? Yeah, good. It tells us that ED is double the length of AB. And we know AB is vector U, so it means if we replace AB with U, we would just have 2U. So that vector there will be 2U. And underlined and put a wee tail on it and show that that's there from E to D would be 2U. It's just double the length of AB. So it's 2 of them. So add on 2U. And finally, to go from D to C. Well, from D to C, it tells us here that EA, going from E to A, is twice the length of DC. So this time here, you can see that EA, pretty much looks it is twice the length of this one. So if we want to get the shorter one, the smaller one going from D to C, we wouldn't double that. What would you do? Yeah, you would half it. So you can say that there would be half of whatever vector W is. So we're going to be adding on half of W. After that, we just want to add our like terms. So look at the U's, look at the W's. How many do you have? So with the U, we've got our 2U, and then we're taking away 1U. Or you could say I've got negative 1U, add 2U. Either way, 2 take away 1 is just going to be 1. So we'd have 1U. And with the W's, you've got negative 1W and a half W. What's negative 1 and a half? Or another way to think about it, what is a half take away 1? Yeah, it's going to be negative a half. So you'd have negative a half W. Yeah! Alternative vector journeys. Don't you love them? Question 7 from the 2018 specimen paper. Thought this was quite a good question. Thought I'd throw this in as well. 2 forces acting on a rocket are U and V. They're represented by vectors U and V. U has a component 2, negative 5, negative 3, and V has a component 7, 4, negative 1. Calculate the magnitude of U plus V, which is the resultant force, and express your answer as a surd in its simplest form. So, how do we do this? Well, first of all, ignore the magnitude part. Just think you're wanting to work out U plus V. We'd have to work out that first of all before we get the magnitude. So don't start off by writing the magnitude is going to be. Just work out U plus V. How do we get U plus V? Yeah, well done, Alan. All you do is you would do these 2 vectors added together. So we've got the 2, negative 5, negative 3. Add on the 7, 4, negative 1. Well done. If you add them together, add the x's, add the y's, add the z's. So 2 add 7. Good. Negative 5 add 4. Good. And negative 3 add negative 1. Remember, when you add a negative, it's the same as take away. So it's negative 3 take away 1. So we're going further into the negatives. That would be negative 4. Good. So that is U plus V. However, we want the magnitude of that. So we can now say the magnitude of U plus V will be... And how do you go about getting the magnitude? Yeah, well done, Tintin. You would have the square root of, and then you've got the 9 squared, plus the negative 1 squared, plus the negative 4 squared, which becomes then the square root of 9 times 9?
81.
Good. Negative 1 times negative 1?
Positive 1.
Good. And negative 4 times negative 4?
Positive 16.
Good. And if you add them together, you would have the square root of
98.
It is indeed. Is that our answer then?
No.
How do you know?
Because there's more green boxes.
Yeah, apart from that though,
It says express your answer as a surd in its simplest form.
it does indeed, yes. We need to simplify this root 98. Remember to simplify a third? Remember to simplify a surd, think about square number multiplied by another number to give us 98. So we want to split up root 98 to be the square root of something times the square root of something else. So when you think about your square numbers, 1 times 1 is 1. 2 times 2 gives you 4. 3 times 3 gives you 9. 4 times 4 is 16. 5 times 5 is 25. And so on. We're looking for these square numbers. You'd have 36 and 49 and 64 and so on. We want one of these square numbers times something to give us 98. And if you keep on following this pattern, you should work out that it's going to be, yes, the square root of 49 times... How many 49s in 98?
2.
Yeah. So that becomes the square root of 49 times the square root of 2. Yes, Lindsay, what are you asking? Why did we do that? Good question. Why did we do that? Why did we replace the square root of 98 with the square root of 49 times square root of 2? Because it asks us. Yes, because it asks us, but also because we know what the square root of 49 is. The square root of 49 is 7, so we can just write that as 7, and root 2 you can't simplify, so it'll just stay as 7 root 2. And that would be your answer. It's how you simplify your surds. Yeah. Question 8. This is from the 2018 paper. Paper 1, so it's non-calculator. The diagram shows a triangular prism A, B, C, D, E, F relative to the coordinate axes. AD, the length of AD, and the length of AE are equal. So that length is the same as that length. And it tells us the length of DC from D to C is 8 units. So we know that you can write that on. That there will be 8 units going from D to C. So front of it to the back of it is 8. Edges EF going from E to F. D to C and A to B are all parallel to the y-axis. Write down the coordinates of B and C. So, it's coordinates, it's 3D coordinates. We want to find this point B. So we're thinking, how far along do you go in the x-axis? How far back do you go in the y-axis? And then how far up in the z-axis? How do you do it? Yeah, well, use what you know to begin with. We know point E is 200, meaning to go from here to here, we came along 2 units. You then went back 0 and you went up 0. For this point A, it's 405, meaning you came along 4 units. That must have been to the center, so from here right the way along there must have been 4 units. Then we went along 0 and then we went up 5. Whee! That would have been 5 units. But we're asked for B and C. But to go from B to C, you can see that what you would do is we still want to go to the center of that triangle there, just on the end. So we would still be going along these 4 units. If we do that, that'll take us just down to this point here.
Hello, look at me.
So our x coordinate will be 4. Then what we want to do is we want to go back in the y-axis. We're wanting to go from here right the way back to the other end of the shape. So we want to go right the way back to here. How far is it from the front of the shape to the back? 8. Good, yeah, it tells us that. We just had that from D to C, and from this point to this point, they're still from the front to the back, so it is 8. And finally, to go from the bottom to the very top, what height do we have to go up? Yeah, 5. It tells us that here. We had to go up 5 units from the bottom to the top for point A, so that one there will be the exact same. So from the bottom to the top is 5 units. So that will be your answer. So we go along 4 units, then back 8 units, and then up 5 units. For point C, how do you do that? Yeah, well, you know you go along 4 units to get to here. I just change the colour. You know you go along 4 units to get to this point here, and it's 2 units from here. Meaning the difference between them, how far is it from here across to here? If you just go right the way along, yeah, that would have to be 2 units. So it's 2 to the start of the shape and then 2 to get to the center. But if you're wanting to go along to here, because we want to get to C, we'd have to go along to D and then back the way. So this part here, well, if that's 2 units there to get to the center, that must be another 2 units. So overall, we've gone along 2, 4, 6. So we'd have to go along 6 units. After that, we are going back, and you can see that from the front to the back, that's 8 units. So we would go back 8. And finally, we would end up then at C. But if we want to get to C, we're already at C, so do we have to go up or down from there? No, we don't. So our Z component, or Z, will be 0. So we'd have along 6, back 8, and up or down 0. Final exam style question from the specimen paper 1 in 2018. Again, paper 1 is non-calculator, not that you would need it here anyway. In the diagram, O, A, B, C, D, E is a regular hexagon with centre M. Vectors A and B are represented by OA, so from O to A, that there is vector A, and OB, going from O to B, is vector B. Tells us that here. So we've got these two vectors, A and B. Express AB in terms of A and B. So, once again, it's the alternative vector journeys. If you've tried the other ones, you should be an absolute expert at these by now. We want to go from A to B. Again, I keep thinking about towns and roads. Do we know what this vector is? Going from A to B? No, we don't. So we need to find some alternative vector journey that takes us from here to here. So what can we do? Yeah, you would first of all have to go back the way to O, and then you'd have to just come up this way to get to B. So if you do that, going from A to O, and then adding on O to B. Vector AO, going from A to O, well, it's the opposite of this line here. You can see vector A is going from left to right, but if we're going back the way, we're doing the negative of vector A. So we'd say that's the negative of vector A. And then vector O to B is just represented by this lowercase letter b. So we're just adding on vector b. So we can say the answer is negative a plus b, or you can always put that the other way around if you like. We've got a positive b and a negative a, so we can say it's a b and a negative a. In other words, b take away a. Both work. Going from O to C, how do we do that? Well, from O to C is going from O all the way up here to C, up to this point. How can you do that? Well, the thing to realise is that this vector going from O to C is going to be double the length of O to M. So we know from O to M, well, we don't know from O to M, but we know if we go from O up to M, we're just really doing that twice. And what you should recognise is that this vector from O to M, it's the same length and same direction as this vector here. Same length, same direction as this first answer. So vector from A to B, because it's same length, same direction as OM, we can say that O up to C is going to be twice the length of AB. And AB we just worked out. We know AB was the negative AB. So we can say that OC, because it's twice the length of OM, in other words, it's twice the length of AB, it's just going to be 2 times by the negative A plus B. And if you multiply the brackets, 2 times negative A gives us negative A 2A, and 2 times B gives us plus 2B. And again, yes, you can rewrite that. You could say that's also 2B, and then take away 2A. It doesn't matter which way it is written, but that's how you do it. Hopefully you are feeling quite confident with vectors. Feel free to try some of the other past paper exam style questions. I've tried to make sure everything that's come up in the exams has been covered in this lesson, but there are a few more since making this video, so give them a shot. If you're unsure about anything, just look back to something similar in this video or the previous lessons. And if you still want more practice with vectors, there's loads and loads of pages and textbooks out there, but this one here is quite good. The TJ National 5 book, page 152, the Remember to Member exercise. Good luck with vectors, good luck with the exam. Do you want a free high five? Here you go, you ready? Woo! Hey, that was a good high five. Well done. See ya.